All right, well, good afternoon, everybody. Thank you for attending our first SKYWARN Storm Spotter training session of the season. My name is Tyler Castillo. I'm a meteorologist here at the National Weather Service office in Corpus Christi, Texas. And since this is our first webinar of the year, I may stop a little bit for some water breaks since I'm not quite used to talking for over an hour straight just quite yet. So let's go ahead and get started. So the agenda for today's talk, we're going to talk about the National Weather Service as well as some severe weather hazards. We'll talk about severe weather climatology, our instruments, concepts, and some severe storms. We'll go over some storm spotting techniques, how you can report to us, and at the end, we'll brush up on weather safety. So first up, about the National Weather Service. So for the Weather Service, there are 122 weather forecast offices across the country. Down here in South Texas, so we are in Corpus Christi, surrounded by the Houston, San Antonio, and Brownsville offices. There are 13 river forecast centers. Our river forecast center is in Fort Worth at the West Gulf River Forecast Center. And there are 9 national centers as well all across the country. And along the way, if you have any questions, feel free to pop them into the chat and I'll get to them as I can. So for our county warning area, or CWA, as I may refer to it throughout this presentation, we have the responsibilities for 15 counties across South Texas, all the way from Victoria down to Clayburgh and out to Webb County across the brush country, and the Gulf of Mexico out to 60 nautical miles. So what do we do with the National Weather Service? We're keeping a continuous weather watch 24 hours a day, 7 days a week, 365 days a year. We're issuing warnings for tornadoes, severe storms, floods, hurricanes, and other weather hazards, such as winter weather, providing the forecast across the region, and just keeping an eye on things, all for our mission of protecting life and property. And these images here on the screen, the image on the bottom right is what one of our typical workstations looks like. We feed all of our radar, our satellite, our model data all into these computers, and from there we can create our forecast, issue warnings, whatever it may be. And on the top left is a weather briefing from a shift change during this past hurricane season. I believe it was either likely Hurricane Nicholas. So that's just our shift change during hurricane season. We have 12-hour shifts during a tropical event, that is, and 24 hours a day. So that was just one of our shift change. So why are you here? Why do we need spotters? Spotters provide real-time weather reports to our office. So you guys are our eyes in the field. So we're in our office using satellite and radar data. You can't actually see what is going on at ground level. So that's where you come in. And your reports give communities downstream time to prepare, allow us to extend our warnings further in time, further in length, based off what you are reporting to us. So if you follow us on social media, you'll see us tweet out a graphic like this or post on Facebook asking for spotters to provide information to us using the hashtag #CCSpotter. And I'll get more into that later on as we talk about how you can report to us. So the problem with the radar, which is where the spotters come in handy. So the radar is our primary tool for issuing warnings. But the problem with that is the Earth is curved and the radar beam travels in a straight line. So our radar here in Corpus allows us to see pretty low to the ground level across the Corpus Christi area, across the coastal bend. But as we get further away from the radar, such as out near Victoria, out towards Laredo, across the brush country, we're looking at least 10,000 feet in the sky. So we can't see what's going on below that. So the more spotters we have, we're able to fill in that gap of what we can't see below, say 10,000 feet. So you can tell us what's actually going on. So another issue with the radar is the cone of silence. You may or may not have heard of this before, but the radar beam shoots out at an angle. It does not go straight up. So surrounding the radar, we can't see anything, which is the cone of silence. You can see that here in this image right here, right around the Corpus Christi radar. You see there's a gap in coverage. Now we're able to fill that coverage in using our surrounding radars from Brownsville, Houston, and San Antonio. But at that point, you're already looking several thousand feet up in the sky. So you're still not gonna be able to see that low level. And here's a cross section of what that looks like as well. So you see the radar beam shoot out at an angle. We can see what's going on in all directions. but directly above the radar, there's a big gap in coverage. So our main South Texas severe weather threats. We have our severe weather, tornadoes, flash flooding and river flooding, hurricane, storm surge, and our winter storms, which we all know about from last year. So let's define a severe thunderstorm. Large hail equal to or greater than 1 inch, damaging winds greater to or equal than 58 miles per hour, flash flooding, tornadoes and waterspouts, and marine winds greater than 34 knots. So let's break down the types of tornadoes first. We have our weak tornadoes, or EF0s, or EF1s. This is most of the tornadoes we see here in South Texas. We will show some examples of these later. Lifespan is rather short, 1 to 2 minutes. Wind speeds up to 110 miles per hour. Most of these are not detected by radar, and they are difficult to get spotter confirmation and go unreported. So with that short lifespan, sometimes they'll form and dissipate in between radar scans, so sometimes we'll miss them. But that's where the spotters come in. They can tell us what's going on, what they're looking at, then we can issue warnings based off their reports. Then we have our stronger tornadoes, our EF2s, our EF3s, about 30% of all South Texas tornadoes. Lifespan's a bit longer, anywhere from say 15 to 60 minutes. Wind speeds up to 165 miles per hour. These are easily identified on radar, often get good spotter confirmation and go reported. And then we have our violent tornadoes, our EF4s, our EF5s. Very rare across South Texas, although they can happen. Lifespans anywhere from 1 to 2 hours, even longer in some cases. Wind speeds up to 200 miles per hour. And again, easily identified on radar, good spotter confirmation, and are reported. So I mentioned marine winds earlier. We do issue special marine warnings for marine thunderstorms. Winds equal to or greater than 34 knots, and for waterspouts and hail. So on average, we issue about 70 special marine warnings a year for our waters. And if you're interested in more the marine aspect, we are offering 2 marine-oriented SKYWARN Storm Spotter classes, one later this month, and the next one I believe is in April. But that's going to be more focused towards the marine aspect side of things, where in today's presentation is going to be more inland threats. So the Storm Prediction Center, or SPC as I will likely refer to it from here on out, issues severe weather outlooks for days 1 through 8 with a bit more details in days 1, 2, and 3. So they issue their risk category for each day, 1, 2, 3, 4, and 5, with 5 being the highest risk there is. On this example here, it's a moderate risk, showing a greater potential of severe weather across this area near Memphis, Jonesboro, Paducah, and we'll actually get into this exact event a little bit later, but talk about the hazards for this particular day. They put on their graphics, their website, scattered damaging winds, tornadoes, hail, provide outlooks for which cities are in this area. So understanding the Storm Prediction Center categories, I mentioned there were 5 of them. And then there's general thunder, so you have your typical thunderstorms, not expecting anything severe. And you have your marginal, your category 1. Some severe storms will produce hail, damaging winds, potentially a tornado or 2. Those are pretty common down here, especially in the summer with the heating and the sea breeze moving inland. Then we have our category 2, or our slight risk. Severe storms will produce damaging wind, hail, and tornadoes. A little bit more confidence in that forecast. We move up to category 3, we have our enhanced. Several severe storms will produce very large hail, damaging winds, and tornadoes. We do get the occasional enhanced risk across South Texas. They're rather rare. The last one that comes to mind was the 2019 Kingsville downburst, which we'll actually get into later. And then we have category 4, moderate risk. Many severe storms will produce very large hail, damaging winds, and tornadoes. And then lastly, your high risk, your category 5. Essentially is reserved for when we're expecting a severe storm outbreak, produce tornadoes, damaging wind, and very large hail. So how do we work with the Storm Prediction Center? As I mentioned earlier, the SPC issues their severe weather outlooks, days 1 through 8, with more detail in the first 3. They can be found at spc.noaa.gov. So we work with them, they issue their outlooks. If we're outlooked in across South Texas and storms are expected to develop later in the day, we'll coordinate with the Storm Prediction Center about a potential, let's say, severe thunderstorm watch or tornado watch. Usually 3 to 6 hours long, can be longer in some cases, issued a couple hours before storms are expected to develop. And then we will issue any of the warnings. So we coordinate with SPC for watches. Warnings are all done within our office. Last anywhere from 30 to 60 minutes long. Could be longer in some cases if conditions are warranted for it. Generally 10 to 15 minutes before impacts, but ideally that time is going to be a lot longer of a lead time. And you can get any of this information on our website at weather.gov/CRP or /Corpus Christi, or your preferred weather app as well. So a watch versus a warning. So what does a watch mean? Conditions are favorable. A watch means be prepared. If a watch is issued, conditions are favorable for severe weather. So pay close attention to your TV, your radio, social media feeds, our website, whatever it may be, and be ready to act if we do issue a warning. And a warning means that threat is imminent or is already occurring. So take action now. Seek shelter immediately, as if we issue tornado warnings, likely will be developing shortly or is already on the ground, essentially heading your way. So when you have a warning, that's when you want to seek action immediately. So let's talk about our severe weather climatology. So this map here is showing all of the slight risks, which are that category 2 from Storm Prediction Center, issued from January 2nd, 2002 through January 19th, 2022. So you can see there's a greater concentration of slight risks issued across the plains, across the Midwest, lesser amounts down here across South Texas. But essentially just wanted to show that they are still possible down here. Although this area is going to be where their greatest chances are, South Texas is not getting out of any sort of severe weather threats. So South Texas does see these kind of outlooks throughout the year. Right here, we're showing a map with the number of severe thunderstorm watches issued throughout the year. So Corpus, we issued 7 last year, Brownsville 3, Houston 10, San Antonio 17. The area where the concentration of the outlooks was a bit higher number of watches, so 24, 28 up here in Oklahoma. And same thing with our tornado watches. We only issued 1 watch last year. These maps are from January 1st through December 31st, 2021. Higher concentration of tornado watches across the plains and the southeastern United States. And I'll show the same thing for severe thunderstorm warnings on the top left, tornado warnings on the bottom right, higher concentration of your warnings across the same areas, same with your tornado warnings. We issued 18 tornado warnings across South Texas last year. A few of them were with our squall lines moving through during the spring months, but oftentimes a lot of our tornado warnings come from during hurricane season, as a hurricane is either making landfall somewhere along the middle Texas coast, bands from a storm will move inland, and will be issuing tornado warnings based off those. These 2 images show the frequency, so the time of day of tornado watches, or severe thunderstorm warnings on the top left, tornado warnings on the bottom right. All I want to relay here is that you can see that tornado warnings, thunderstorm warnings can happen at any time throughout the day. There is a peak during the late afternoon to the evening hours, but there's no time on this map where there's never been a warning issued. So warnings are possible throughout the day. So we're under a watch. We know we're expecting severe weather. Continue to pay attention even after you go to sleep at night. And I mentioned our special marine warnings. A few minutes ago, I said we only issue on average 70 per year. And then this past year, we issued 120. So some years are more active than others when it comes to our special marine warnings. And last year just happened to be one. You see that down here along the northern Gulf Coast, they issued significantly more than we did, almost 600 at the New Orleans office. So let's talk about our instruments, concepts, and a little bit about severe thunderstorms. So I mentioned the weather radar earlier. There are 155 radars nationwide, continuously operating 24/7, 365. These only detect rain and aerosol particles in the atmosphere. They do not detect what is actually reaching the ground. So during severe weather, we can change the mode that these radars are operating. We can actually get new scans every 1 to 2 minutes. On a day like today where there's no severe weather threat, we get updated about every 10 minutes or so. So we don't want to put too much stress on the radar. And you can see here's the map of all the radars nationwide, and there is bits of gaps in coverage, which is where spotters come into play. For our area, South Texas, we have our radar down here in Corpus. You come across the brush country and there's nothing. So when even using the Brownsville and Del Rio radars, you're still looking about 10,000 feet into the air when you're looking across, let's say, Webb and LaSalle counties. So how the radar operates. The radar will transmit a horizontal pulse, then receive that horizontal pulse, then transmit a vertical pulse, and then receive that vertical pulse. And all that information, when it bounces back from any of the, the rain particles, the water droplets in the storm, come back to our radar. All that data will be analyzed, and it'll be able to give us our radar products that you've often seen potentially on your phone, on the TV, on social media. So we're going to show a couple of these radar products. One you are likely familiar with is reflectivity. So the more intense colors here, your reds, your pinks, are the more intense storms. When you get to that white and pink color, that typically indicates some potential of hail. That's showing a very strong storm. And we'll show examples of that here in a bit. You get your cooler colors, your blues, your light greens. That's going to be your lighter rainfall. Another popular parameter is velocity. It shows you the direction the storm is moving. So your warm colors, your reds, are moving away from the storm. Your cooler colors, your greens, away from the radar. Your greens are moving towards the radar. And when they line up next to each other, like in this example right here, you have your outbound, your reds moving away from the radar, which is over here in this example. Then you have this side moving towards the radar. So that's showing some tight spin right here, potentially a tornado. You can't confirm this based off radar, but that's where a potential tornado would be. And in this example, you can see in this pink polygon that a tornado warning was issued. Another product we use is the GO16 satellite imagery. This gives us 1 minute imagery available in some instances. We can get updates even faster. So the data from the satellite is ingested into weather models, providing more accurate forecast. The satellite is in geosynchronous orbit about 22,000 miles away, so it's always staying in the same spot. And this 1 minute satellite loop here is from Hurricane Harvey as it made landfall on the Texas coast back in 2017. So we also have weather balloon observations. There are several offices, but 92 offices across the country that launch weather balloons at least twice a day. Right now that's at 5 a.m. and 5 p.m. for the 12Z and 0Z balloon launches. All that data, we collect temperature, winds, moisture, data throughout the entire atmosphere. All that data is analyzed and sent into our office. We also can put all that weather balloon data into our weather models to provide an even better forecast as it initializes better. In this video I'm about to play right here is our 18Z balloon launch, so middle of the day balloon launch from Hurricane Nicholas. So I know I just mentioned we do balloon launches twice a day at 0 and 12Z, and then we showed you a video from an 18Z balloon launch. So what that is for, just oftentimes during hurricane season, as a storm is threatening either our Gulf Coast or really any coast of the United States, we'll launch 2 more balloon launches a day. So 4 times a day, help provide better and more accurate forecast information so we can get a better sense on the intensity and direction these storms will eventually take. So we also have surface observations located all across the country. Often most airports will have a ASOS system, or an automated surface observation system, which is what's right here in the photo. We get temperature, dew point, pressure, wind speed, what type of precipitation is falling. Tons of data provided by these systems that feed right into our office. They're also available online, so you all can look at the observations at home. And this data is also fed in to weather models to have a better model start. So now we'll look at some thunderstorm ingredients. For your typical ordinary thunderstorms, think of your thunderstorm along a sea breeze over the summer. So you have 3 main ingredients: your instability, your moisture, and your lift. So now we'll go ahead and talk about each of those. If your instability, which we measure as something called CAPE, or convective available potential energy, this essentially is a measure of an air particle's tendency to accelerate upwards after being lifted. So the greater the instability, the greater the potential for severe storms. So where does instability come from? It's heating from the sun. So if we're expecting severe weather one day and you go outside and there's hardly any clouds, it's just really warm, that's a sign that the atmosphere could potentially, really explode later in the day. So that lack of clouds, we're getting warmer, allowing the instability to continue to increase. The atmosphere is continuing to destabilize, but there's a bit of a lid on the atmosphere at the time. As instability continues to increase, that cap over the atmosphere will pop and we'll be able to see storms develop. So if you don't want storms and you go outside and it's cloudy, not as much heating, that's a good thing. You also need your moisture for storms to develop. If there's no moisture, you can't have storms. So across South Texas, our main source of moisture is the Gulf of Mexico. Our persistent southeasterly winds through the year provide ample moisture across the region. But we also can tap in through the Pacific Ocean from time to time. We'll have hurricanes making landfall in the west coast of Mexico. That moisture will take the journey over the mountainous terrain of Mexico and then feed into South Texas, and we'll have severe storms, potentially oftentimes flooding, as that moisture surges into our area. And we need lift. If there's no lifting mechanism, storms can't develop. So we can have a large-scale lift, such as a cold front, your dry lines, but also small-scale boundaries can create storms as well. So think of your daily summertime sea breeze or any outflow boundaries from other storms. These all have the potential to develop thunderstorms, but we can't have thunderstorms without any lifting mechanism. So speaking of general thunderstorms, you can think of the life cycle in 3 stages. Over here, we have our towering cumulus stage. The storm is continuing to grow, very little rain. The storm is still building. You can see it is all updraft at this time. We move over to our mature stage. Intensity is increasing, starting to see a bit more lightning with this storm. And our tornado potential is also increasing. So with this, you can see we still have our updraft in this part of the storm. But now over here to the right, we have our downdraft. So that's helping the storm stay alive a bit longer. We have our updraft over here co-located with the downdraft. Eventually, this downdraft will cut off the updraft from the storm, bringing us to our dissipating stage. So there's no more updraft. So everything's falling out from the storm. Intensity begins to decrease, but our potential for our downburst is increasing. And I have a example of a downburst here in a couple minutes. So then if we want a severe thunderstorm, we add one more ingredient. We have our wind shear, which is a change in wind speed and or direction with height. So a few examples of that right here. this image on the left, this is our ordinary thunderstorm. Updraft growing up. There's no real change in wind speed or direction with height over here. The storm just grows up, doesn't increase too much, no additional strengthening. But over here, where we have our winds, which is these black arrows, you see it's a little bit lighter at the surface, gets stronger as we get further up in the atmosphere. Your updraft grows. Stronger winds aloft will actually tilt your storm downstream, so to the right in this instance. Then the downdraft begins to fall out from the storm, but it's further away from the updraft. So this example here, they're pretty much co-located, so the storm will die out pretty quick. A severe storm, downdraft is further away from the updraft, which allows the storm to exist for a longer period of time. Then over here is an example of the change in wind direction with height. So at the surface, more of a southeasterly wind, a bit higher up, more of a southerly wind, southwest, then a westerly wind as you get high up in the atmosphere. Now we'll talk about some common types of severe thunderstorms. So you have your single cell, weak, brief updraft, usually not severe, but they can be. You see these often along the sea breeze I continued to mention. We have our multi-cell cluster or a line of storms, which we'll see around here during the spring a lot when we have our squall lines surge across South Texas. A moderate updraft, when severe, the main threats are typically wind and hail, but we still can have tornadoes embedded in these lines. And then we have our supercells. An intense updraft almost always are severe. Wind, hail, and tornadoes are all possible. I guess going back to the ingredients real quick, I mentioned a weak, brief updraft here with our single cell. It's because there's not much wind shear. As we move down this line right here, we have gradual strengthening or increasing wind shear. So the supercell is going to be where wind shear is the greatest. So for squall lines, these require moderate to strong wind shear. They have a linear appearance on radar. The shelf cloud will be the leading edge, which is in this image right here. So leading edge of the storm moving to the right direction in this image. These can be long-lived. Oftentimes it will be severe, can produce hail and damaging winds, and sometimes tornadoes. Now there's a couple of features to keep an eye on when you're looking at squall lines. So we have these nubs that develop on the leading edge of these lines. And as you see that small appendage stick out from the front and begin to curl back in, that is often when we can see tornadoes develop along squall lines. So if you're watching radar and see this feature begin to develop, there could be an increasing sign of a tornado right there. And typically these tornadoes are short-lived, but we can and have seen longer lasting tornadoes with these squall lines. Another example is this bowing segment. So you can see in this example, that's a storm near the coast. This part of the storm is surging out ahead of the rest of it. Really bright reflectivities, those pinks, those whites in here, indicating a very strong storm, likely some large hail in there. But as the storm bows out, known as a bow echo, that's gonna be where your strongest winds are. You can help identify that from what we call a rear inflow notch. So these are strong winds causing that bow to form, or that part of the storm to surge ahead. And you can see these inflow notches right in here. You have this decreasing reflectivity, this little finger-like appearance right behind this part of the storm. That's going to be your rear inflow notch with that descending air, forcing that out ahead. So that's your rear inflow notch, right, with your bow, and your appendage for tornadoes are a couple of features to keep an eye out on with these squall lines. Then we have our supercells. These require moderate to often very strong wind shear. These can be long-lived. You have your mesocyclone or intense storm scale rotation throughout the entire depth of the storm. Most of the time, these are isolated, but they can be embedded in lines. These produce large hail, damaging winds, and tornadoes. And they're identified by that hook echo appearance on radar. And these pose a significant threat to life and property. So this example here is a North Dallas tornado back in October of 2019. As a storm surged to the north of Dallas, you can see that hook appearance with a tornado right in this area. Appearing on radar, reflectivity on the top left. Come over here to the top right, we have our velocity couplets, so our outbounds and inbound winds with that very tight velocity couplet right in this area. Come down here to the bottom left. This is the correlation coefficient. The correlation coefficient measures how uniform the atmosphere is. When it's close to completely uniform, you have these more reds, purple colors. As you start to detect other unnatural objects, being tossed up from a tornado, as an example, the correlation coefficient is lower. So we start to see these blues. In this example, this is showing that debris ball right here as debris is being lofted by this tornado north of Dallas. Shows these blue colors where debris is being thrown into the air. And on the bottom right, we have a parameter called spectrum width, which essentially measures the amount of chaos in the atmosphere. So help you determine where the winds are most chaotic. So for a supercell, we'll break down the parts real quick. You have your updraft, going to be feeding into this section of the storm, followed by your downdraft on the other side. Remember, for a supercell, your updraft is going to be not necessarily co-located with the downdrafts. They can help, the storm will stay alive a bit longer. So when you're looking at a supercell on radar, closer to the core area near that hook is where most of your action is going to be. If you have a tornado, your larger hail. As you get further away from the center of the storm, you're going to have some smaller hail, and then mostly rain out here further away from the storm. And we'll show a few more better examples and the actual what the clouds look like associated with these features here in a bit. So some common cloud features with storms, you have your updraft and your downdraft, which is going to be the most important thing you can learn if you're out in the field trying to chase a storm, or you happen to just be outside and see a storm forming, and you want to report back to us. You need to make sure you know where the updraft and downdraft is. So this will help you, identify different supercell storm features and be able to identify clouds that may indicate that tornadoes are forming. So different sorts of clouds you might be able to pick out and show whether or not a severe thunderstorm is possible, direction the storm is moving. So when we look at updraft and downdraft, the main difference is how the air is moving within them. With an updraft, the air is moving upwards. The downdraft is moving towards the ground. So updrafts, in a sense, act like a vacuum for all that heat and humidity. They essentially suck up the moisture needed to form a thunderstorm. While downdrafts, on the other hand, are more of a vent for the storm. Kind of serve like an exhaust pipe on a car, moving the air that has already been used, the fuel to get for the thunderstorm out of it. In addition to the rising air, one of the best ways to identify the updraft is that there's going to be no rain underneath it. In a downdraft, however, that's where all the rain and hail forms. So tornadoes, if you're looking for those, will occur in the updraft portion of the storm. This means you won't find them in the downdraft. And you really, looking at the downdraft, won't be able to see anything in there, as it's going to be completely covered with rain or hail, and visibility will be very low. In the bulk of the storm, about 80 to 90% is going to be downdraft, where the updraft only takes up about 10 to 20% of a mature thunderstorm. So now that we have a better understanding of the updraft and downdraft, we'll go ahead and talk about a few different features associated with a thunderstorm. So on the left, you see is look at where the warm air rises. This red line is going to be your updraft. And then on the other hand, with the blue line is going to be your downdraft. So in this image, you notice the updraft is tilted, not straight up and down. That is due to that wind shear we talked about. The change in the wind speed in direction with height tilts that storm, allows the updraft to continue on, as the downdraft over here with your rain, your lightning, your hail is able to continue as the updraft helps to keep feeding the storm. So a few of the cloud features associated with this you might recognize is going to be an overshooting top. So it's going to be where the updraft is so strong that parts of the storm push out ahead of that equilibrium level, or really the top of the atmosphere where you don't expect clouds to develop anymore. But in this case, these storms can be so strong that you can have a brief period where storms or clouds do develop ahead of that area. Another feature to look at is the flanking line. which is going to be down here on the left side over here. Your flanking line is going to be a series, almost like a stair-step appearance of just cumulus clouds leading into the storm. So that's going to follow along your updraft. So I'll show a picture of that here in a minute, but you'll be able to see almost a updraft feeding in to the storm from the flanking line. Then you'll have your shelf cloud down here on this end, which is going to be the direction the storm is moving. Your wall cloud down here on the bottom, it's going to be pointing towards the downdraft, while your shelf cloud is pointing away from the downdraft. You'll have your anvil, top of the storm, in an area of the Mattis clouds, which I'll show here in a second. So a few cloud types, I'll show actual pictures this time instead of drawings of them. So these might often be called turkey towers. They are vertically developing clouds indicating the weakening of that capping inversion. So earlier I mentioned that summer day where it's warm but there's no clouds out because there's that lid on the atmosphere. And as that lid or that cap begins to weaken, you start to see clouds like this form, showing that vertical motion is happening in the atmosphere, showing conditions are favorable for additional storms. So you have your strong updraft, which is a sign of a strengthening storm. Clouds will eventually hit that equilibrium level and then push out horizontally in all directions. And you may see this little feature up here, which I already mentioned once, which is your overshooting top. This is a good indication that a storm is very strong, potentially severe. Forms from the momentum of the updraft is so strong that it lifts through that top of the storm. And these typically don't last long, but if you catch them, they're pretty cool to see, and you can also see them on satellite as well. So wind shear will result in a tilted or a rotating updraft. So air on this side feeding into the storm. As it's moving upwards, that change in wind speed and direction will allow for rotation to develop. And that's noticeable from these striations within the storm. I have a couple better examples of that here in a second. This is what's known as the mesocyclone, that storm scale rotation within these supercells, which is oftentimes strongest in the mid-levels. I mentioned the wall cloud earlier. We're going to look for a lowering cloud base in the updraft area. Rotation and lowering should remain persistent with a wall cloud. It's going to be pointing towards the downdraft. In this case, the downdraft is going to be over here in this region. Directly beneath mesocyclone is where it's going to be located. And tornadoes may form beneath this wall cloud. So this is the area you're going to be looking for if you are trying to find a tornado. We have our funnel clouds. They're found underneath the wall cloud, and they're not in contact with the ground. So you may see this if you're out in the field, think it's a tornado. As long as it's not touching the ground, it's technically not a tornado. So you could call our office, let us know there's a funnel cloud. That is a pretty good sign that a tornado is possible within the storm. But until it makes a contact, it's just a funnel cloud. So landspout, these are typically formed from non-severe storms actually. This example here I'm going to play was from, I want to say, last year. There's no rotation within the storm. You can see this tiny landspout feature just outside of Corpus Christi. And this was very short-lived. It was actually developed in between radar scans. And what happened was there were two outflow boundaries collided during one afternoon, produced this weak rotation, and produced a brief landspout across the area. So here are a few more examples of the mesocyclone, the supercell. You have your updraft and your downdraft, an intense storm scale rotation, resulting in these striations across the storm. You can see that rotation all the way up through the column. Same thing in this image here. I'm just showing just how that wind shear plays a role to help these storms really survive for long periods of time. So if you're out storm spotting, you want to make sure you know the different parts of the storm, what you're looking at. Down here on the right, or excuse me, down here on the left, you have your rain-free base. This is where your updraft will be. Mentioned earlier, no precipitation in this area. As you go up in the storm, wind shear is present, so you see it is tilted to downstream. See some striations and some rotation beginning to form. Not a super intense storm, but as you look downstream, you have your downdraft falling away from the storm, away from that updraft, closer to the center of the storm, you have your large hail, your smaller hail with rain, and also as you get further away, you have more rain as the hail will not survive the further away you get from this updraft area. So I mentioned the flanking line, kind of that stair-stepper appearance as you head into the updraft of the storm. This is kind of what it's going to look like in some cases, just an organized zone of cumulus clouds connected to and extending outwards from that strong to severe storm. Mentioned the mass clouds earlier, oftentimes seen ahead of the anvil. Now these are not severe, but they do often accompany severe weather. They're caused by sinking air as that updraft is so strong that this warmer air tries to go back down, it gets stuck, resulting in these pouch-like appearance in the atmosphere. And this one down here on the bottom right was taken outside of our office. This is where we launched our weather balloons from. I see the mass clouds across the Corpus Christi area. We mentioned downburst earlier. So there's two types of downbursts. We have our microburst. These have a diameter of less than 2.5 miles, last anywhere from about 2 to 5 minutes, and can produce winds up to 168 miles per hour. And then we have our macroburst, diameter of 2.5 miles or more. These last longer, anywhere from 5 to 20 minutes in some cases, produce winds up to 135 miles per hour. And the image here on the right is the initial stage of the storm, where you see this ball of moisture, essentially the downdraft part of the storm falling away from the storm. As the updraft's cut off, and the entire downdraft descends towards the surface. As this hits the surface, it spreads out in all directions, which can be seen here in this radar image. The bottom of the screen is going to be your microburst signature. As this hits the surface, you have some winds moving towards the radar, some moving away from the radar, these greens and reds, showing that wind spreading out in all directions. So at the impact stage of a downburst is when the strongest winds are going to be the greatest threat to aviation. So as this rain-cooled air descends on the surface, it's going to hit, spread on all directions, and have this foot-like appearance on the tail end of it. You can see it even better on this image here on the left. That's going to cause impacts to a plane's lift, potentially throw the lift off of a plane, resulting in a car crash, or excuse me, a plane crash. We'll show another example of a downburst here in a bit. There was one in Kingsville a few years ago, which is one of the examples we'll show here today. Mentioned a shelf cloud earlier, the leading edge of the storm, pointing away from the rain, away from the downburst, or excuse me, away from the downdraft. So just a quick quiz, no need to answer in the chat or anything, just kind of for yourself for which one is the shelf cloud and which one is the wall cloud. So if you guessed option A, which was shelf cloud, you were correct, pointing away from the downdraft part of the storm, pointing in the direction it's going. That rain-cooled air is also surging ahead as well. And option B is our wall cloud. So it's pointing towards the downdraft, where your updraft is pointing towards that rain shaft of the storm. And we also have our outflows and our outflow winds. It's gonna be the leading edge where that shelf cloud is. Air is flowing out and away from the center of the storm. And this air is going to be rain cooled, so it will feel a lot colder than the ambient temperature ahead of the storm. So we're about halfway through right now, a little bit more than halfway. So maybe we'll go ahead and take, say, a 3-minute break, and then we'll get back at it. All right, well, it's been a couple minutes now, so we can go ahead and get back. I got a question in the chat asking when severe weather kicks off this year. There's really no break in severe weather throughout the year. There are times we have lulls, or severe storms are less likely to happen, like during the winter months, but they have happened before in the past. As we head into later this month, especially into March, is where we're going to start to see our severe thunderstorm chances increasing across South Texas. We have cold fronts coming down across the area, and also at the same time, we're getting warmer as we head into the spring and summer months across South Texas. So as we head into the next next 2 months is where we're going to start seeing our severe chances begin to increase and persist through the summer. So we're going to get back at today's webinar. We'll go ahead and go through a few examples of severe storms from across our area and other parts of the country. So I mentioned the 2019 Kingsville Microburst earlier. We were under the enhanced risk from the Storm Prediction Center. So expecting widespread damaging winds, large hail, and isolated tornadoes. For the way outside this enhanced risk across our northern counties is going to be the same risk, but just less chances, less coverage than what we're expecting up in this area. With this event, we did see strong damaging winds throughout Kingsville. So if we take a look at our atmosphere over here on the right, this is the result of one of our weather balloons. This is the evening balloon launch on June 7th. So we can see here is we have our wind shear. So we have our change in wind direction with height at the surface. We have our southerly winds, almost more southeast. As we go up, we have more southwest, westerly winds aloft, and also increasing with speed. So we're about 5 knots here at the surface, anywhere from 25 to even 45 knots as you get further aloft in the atmosphere. So that's showing that increasing wind shear. I mentioned CAPE earlier, our convective available potential energy, so instability of the atmosphere. Values are very high, approaching over 4,600 areas across for CAPE across South Texas, and that's really high for around here. Typically, you can get some thunderstorms with around 1,000 joules per kilogram of CAPE, and it varies where you're at. Also, what's going on with the atmosphere, but approaching over 4,600 is rather high. This entire area here is showing that potential for severe weather. So what happened with this event? This is the radar from the Corpus Christi radar as the storm moved through. Storm moved across the coastal plains towards the coastal bend, heading towards the Kingsville area. You can see reflectivity here on the left. This purple is this white, showing likely chances of some large hail. Strong winds down here with these bright red colors moving away from the radar. I'll let this loop through one more time. So as these are storms moving towards Kingsville, red shows the storm moving away. You start to see these brighter colors showing stronger wind speeds at the same time. We did issue a tornado warning as well, as there were signs that it could have been a brief spin up. As we did our storm survey, we decided there was no tornado with this event, all just straight line winds. But at the time, it did look like there could be a potential for a brief spin up. We had a severe thunderstorm warning out, as well as a tornado warning, and the special marine warning as these strong winds are moving offshore towards Baffin Bay and off the middle Texas coast. So here's another example of that downburst. This was a microburst in this case. So this 3D view of the storm, you see these reds, these purples building up into the storm, and eventually continue to fall out. So you can see these purples coming down to the surface as it heads over Baffin Bay. The main core of the storm falls out. Over here on the right is more of a cross-section view. You see the storm continue to build. Core of the storm, these reds, these purples grow up to about 50,000 feet up into the atmosphere, and then the entire core falls out across the southern coastal bend. So that's when we see the greatest impact with these microbursts. It's very strong winds occur as this core of the storm falls to the surface. So we went out on a survey the next day, determined that there was a microburst from 7:15 to about 8 p.m. to about 45 minutes. So it's a bit longer than usual for microburst. Peak winds of 80 to 90 miles per hour. Path length was about 60 miles wide through parts of Kingsville near the university as well. Width was about 2 miles wide or so. And luckily, there were 0 injuries and 0 deaths. So I mentioned we had a tornado warning issue. We did our storm survey, and all of the debris was pointing in the same direction, which indicates that this was more straight line winds. If it was tornado, you'd see some more twisting debris laying in other directions as that rotation moves through. So that was our main indicator that this was straight line winds in a microburst rather than a tornado. So we had a squall line back in 2018. This example here, if you've seen our presentation before, I've used this in the past, but it really shows the best representation of most of the tornadoes we see across South Texas, these squall line tornadoes that can develop and then only last for about a minute or two. So with this event, we had some large hail across South Texas, winds greater than 60 miles per hour as storms developed across the brush country and moved east overnight. Peak wind gusts of 81 miles per hour offshore, as well as 3 tornadoes. So the first tornado was in Seadrift. It was an EF1, peak wind of 110 miles per hour. It had a length of only 0.4 miles and a width of 150 yards. So it wasn't on the ground for long, flipped several homes, completely destroyed one mobile home in the city of Seadrift. Several roofs sustained damage and the vehicles were also damaged as well. You can see decent rotation right here with this part of the storm, likely dissipated before the next radar scan. We can see those outbounds and this inbound winds along the leading edge of the squall line. We also had an EF0 in Holiday Beach, 1:25 a.m. So a series of nocturnal tornadoes. This is only on the ground for 1/10 of a mile. So very quick spin up. The width is only 30 yards wide. See here in the rotation, you don't really even have that tight couplet. So you have your outbound and your inbound winds. For these stronger tornadoes, you'd like to see them a lot closer together. But we did have a pretty broad rotation with a history of potential spin-ups with this storm. We did issue a tornado warning. There was that brief tornado on the ground. We actually, on a survey, talked to a family that was rebuilding their home after Hurricane Harvey. That had they rebuilt their home after Harvey, and then this tornado came through and ripped the roof off and also tossed it onto a home that was also being rebuilt after Hurricane Harvey. And we had another EF0 with this event at 12:56 a.m. Peak wind of 80 miles per hour. Width was just over a half mile and 75. The length is just over a half mile and the width was 75 yards. So you can see still another broad rotation, not that tight couplet that you want to see with the supercellular strong tornadoes. Again, there's another EF0, but just a really brief spin up that if you're not keeping an eye on close eye on radar, you might miss something like this. So I mentioned how hard tornadoes, these brief spin-ups, are to miss. We have an issue with that with waterspouts. Waterspouts are extremely hard to catch because they can be brief spin-ups and they're dissipated before the next radar scan. So this example here near Port Lavaca, see this waterspout formed out over here across the bay. And this is what the radar looked like at the time. Not a lot of rotation out there, nothing super evident. So you can have these waterspouts develop, they're not gonna be super strong, but they're very tough to catch sometimes on a radar. So I mentioned earlier about supercells and they're a lot easier to catch, more identifiable. So this is from that Paducah, Paducah CWA up in Kentucky. There was a strong tornado back in December. This is the example of that severe weather outlook from the first couple slides of this presentation. So this was supercell. Up here on the top left was you have your hook echo, that strong ball of reflectivity right there. Your top right is going to be strong velocity, strong inbound and outbound winds, unlike the examples I showed on the last slide with that weak rotation across South Texas. Bottom right is just showing your storm relative velocity supports that strong rotation, very tight couplet with your inbounds and outbound winds. And then I mentioned correlation coefficient earlier on the bottom left. You have your more uniform atmosphere surrounding it. Then in this area is where you're gonna have a bit more cluster of what I'm looking for, non-uniform atmosphere. So you have debris in there. It's what we call a TDS, or tornadic debris signature. It's evident with this ball of reflectivity at the same time, co-located with this low area of correlation coefficient values. And a cross section from the storm actually shows debris. So this is your correlation coefficient being lofted up into the storm about almost 30,000 feet into the air. So whether it's trees, roofs, vehicles, whatever it may be, was being picked up and tossed about 30,000 feet in the air before being thrown however many miles away from where it initially started. So here's just another radar view of the storm. Another rotation is hard to see with the city names on here. We just wanted to show what it looked like in motion for a brief second. So there was a storm survey done after this event back in December. So there's a peak wind when we're looking at this track right here. So a peak wind of 190 miles per hour. This is on the ground for 165.7 miles with a width of a little over 1.13 miles. It's a very wide, very long tracking tornado. Catastrophic damage, at least 308 injured, 56 deaths. And this wasn't even the only long track tornado with this event. The storm over here to the south traveled 122.7 miles with a peak wind of 160 miles per hour to this event. And this is just a brief look at two of the tornadoes from that day. You can see there were other tornadoes that started out over here, went just north of Nashville. There are several other tornadoes that occurred throughout this tornado outbreak back in December. So if you're out in the field, here are some storm spotting techniques you can take home with you. So what are some spotting problems? Mentioned in the downdraft area, it could cut off, make the tornado partially invisible, or even completely obscured by rain, depending on where you're located. So that's gonna be very dangerous. If you're out in the field, don't have a good escape route, and you lose track of where the tornado is, it's gonna make it hard to determine what direction it is moving in. Is it coming your way? Is it heading off to your north, your east, wherever you may be? You always wanna make sure you can see the tornado. Some other spotting problems is potentially getting false reports. So when you're looking for a tornado, you want to make sure that is in contact with the ground. You have a smooth rotation appearance, and it will be rotating. So what's not a tornado is a funnel cloud. It's going to have that same smooth appearance as your tornado, but it's not going to be touching the ground. And oftentimes we have scud, which will be confusing to some people. You determine it's not a funnel or a tornado because it has this more ragged appearance. It does look like it's extending down to the ground, and it can show like a rising kind of rotating motion to it, but it's not. And it's not a tornado, it's just low-lying clouds. It's gonna have that more jagged approach to it. So that can help you determine whether it's scud or whether it's a tornado. So the spotting strategy, you wanna find your updraft, you wanna find your downdraft. Because remember, you're not gonna be able to see anything hardly in your downdraft, and your tornado is gonna be in the updraft region anyways. So you wanna be able to find your storm, find the most favorable spot for severe weather, and also make sure you're a safe distance away from the storm. So be aware of your surroundings. Make sure you know the direction the storm is moving. You wanna keep a safe distance away from the storm. Don't get too close, because even if the storm looks like it's gonna move off to the northeast, storm could quickly curve, and you might be heading more east and right to you. So you want to make sure you have a good escape plan. Some parts of the country have better road networks where you can more easily just drive off right to the south, maybe back to the west, whatever direction you need to. Or some parts have more winding roads. You might end up putting yourself right back into harm's way as you're trying to escape. So make sure you know where you're at. You have a map, whether it's on your phone or your car, whatever it may be. Just make sure you know, or you have an escape plan if you need it. So you want to make sure you keep a safe distance. I keep hitting on that because it's very important. You don't want to get too close and realize you're too close after it's already too late. And nighttime spotting is not recommended because you can't see anything. This tornado here, you can only see because it was lit up by lightning. So this is really going to be the only time you can see tornadoes at night, is if there is lightning, or let's just say it happens to be going through a community and is hitting transformers, lighting up the sky, which is unfortunate, but that's going to be one of the only ways you'll be able to see these at night. So nighttime spotting is not recommended for your own safety. So how can you report to us? This is going to be very important. So what is a good report? A brief call or social media update to your local National Weather Service office, whether it's our office here in Corpus, if you're from out of town, or wherever your local office may be. You want to be specific with what you saw. What did you see? When did you see it? And where did you see it? So you can either give us a call, I'll give you a second to write down these numbers, toll free 888-579-9731, or a direct line to our office, 361-289-0959. We answer the phone 24/7. We're always there. You'll talk to one of us in the office. Might answer the phone with National Weather Service, Tyler, how can I help you? And say, hey, Tyler, I'm out here outside Corpus and looking at a tornado moving off to the northeast, wherever you may be. Just a really quick call, let us know what you're seeing, provide that report, and it's very appreciated. Don't want to give us a call? You can use social media. We're monitoring our social media feeds on Twitter and Facebook, so you can find us at WS Corpus, monitor 24/7. You can send us pictures or reports. If you don't want to tweet to us, if you're not sure what you see and don't want other people to see your post, whatever it may be, you can send us a direct message. We're always monitoring, especially during severe weather events. Oftentimes we'll see a graphic like this tweeted out from our accounts whenever we want to remind everyone to send in reports. So we'll measure, show what to measure with hail, winds, tornadoes, funnel clouds, wall clouds, and any sort of flooding. And if you want to be part of our more localized spotter network, feel free to use the hashtag #CCSpotter. Another way, if you want to report anonymously, is to use the MPing app. This is available on both iOS and Android. Reports will be sent directly into our office and will notify the meteorologist who is currently working. It will pop up on the workstation that report was just sent in. It's very user-friendly. You go right to your app. You can select report type hail, wind, you can even report fog, flooding, whatever it may be, and it'll take the location from your phone and it submits the report and sends it right to your local weather forecast office. So how can you get National Weather Service alerts? So you want to always be able to receive warnings. Conditions can change rapidly, so you always want to make sure you're staying aware. You'll get mobile alerts on your phone for tornadoes, strong, very severe thunderstorms, not just the basic severe thunderstorm warnings, but when you have that catastrophic severe thunderstorm is where you're going to have alerts for those. You won't receive everything for severe storms and floods, but just a few. Extreme winds, hurricanes, tsunamis, storm surge, and winter weather. So you can also receive warnings for your weather radio, local TV, outdoor sirens if your community has those, websites, and also just general word of mouth. And for a list of weather apps we recommend, head to weather.gov/subscribe. So I mentioned alerts on your phone. Wireless emergency alert, or WEAs, are free notifications on your smartphone and can indicate hazardous weather. There's several types you'll get: tornado warnings, flash flood warnings, severe thunderstorm warnings. I already mentioned these. So I mentioned not every severe thunderstorm warning is going to alert on your phone. They will only go off on your phone when the hail size is expected to be larger than baseballs and winds are greater than 80 miles per hour. So for our lower end severe storms, greater than 1 inch, and winds greater than 58 miles per hour, you will not receive that wireless alert. So now we'll briefly hit on some weather safety. We'll go a little bit quicker through here so I don't have to keep you all afternoon. We'll talk about some lightning safety first. So 1 bolt of lightning can measure about 50,000 degrees. Typically will strike the tallest object, but not always. Contrary to popular belief, they can strike the same place twice and can strike more than 10 miles away from the center of the storm, or a bolt from the blue, as you may have heard them called before. So if you're close enough, if you hear thunder, you're close enough to be struck. So our saying is, when thunder roars, go indoors. So make sure you stop all outdoor activities, seek shelter in a building or a hardtop vehicle, and then wait at least 30 minutes after you hear that last thunder to resume your outdoor activities. If you're out on the water, thunderstorms pose a hazard to all mariners. They bring dangers, winds, and lightning. So you see a storm forming, or if you get an alert on your phone about a storm heading your way, so a special marine warning, be sure to head to safety. We try to give ample lead time, especially with special marine warnings, as it's quicker to get to safety if you're on land versus if you're stuck out middle of, let's say, Corpus Christi Bay, or you're out in the Gulf of Mexico. It takes a bit more time to make sure you get to safety. So tornado safety, you want to stay away from windows, your doors. You want to act quickly and get to safety when you get that tornado warning. So get to a safe room, your basement, or the middle of your home. You can see here in this image at the top, middle part of the home is still standing. This is what it looked like before. When we say get to that basement or the middle, we mean it. Tornado safety in schools. Seek shelter in hallways or an interior room. You want to avoid large open areas such as gyms or auditoriums. It's not going to be as structurally sound, and oftentimes will be destroyed. As you can see down here, this auditorium, this picture of this school was destroyed. So if you're in your vehicle, you want to make sure you abandon your vehicles for a reinforced shelter. You never want to put yourself in harm's way in your vehicle. Tornadoes can easily pick up a tornado or a vehicle and toss them several hundred feet. I mentioned earlier that debris was being lofted up 30,000 feet in the air in that tornado back in Mayfield, Kentucky. So you see an example of a car tossed upside down in this photo. This is a school bus completely destroyed by a tornado. So make sure you get out of your car into an actual structure. So for flooding, so what causes flooding? Intense rainfall, persistent rain over a long period of time. Could be a dam failure or release, high tides and storm surge, and one that's not really an issue across South Texas are ice jams. So types of flooding, we have our flash flooding. Flooding develops quickly as a result of that intense rainfall or a dam failure. Have our river flooding, occurs when water escapes the river banks. And our coastal flooding, so flooding along the coast from either higher than normal astronomical tides or storm surge from an approaching tropical system. So what does our flooding timeline look like? We have our, before the event, we're messaging what we're expecting. We have our alerts, or we have our flood advisories out, so we're seeing some rain, some more nuanced flooding, upgrade to a flash flood warning, and then a flash flood emergency if we're starting to see more water rescues, water's getting people's homes, that sort of thing. So a quick update to our National Weather Service flood products. We've been simplifying everything we're doing, so our flash flood watch and our flood watch are now just consolidated to the flood watch. Same thing with the advisories. So there's gonna be no more urban and small stream or just small stream advisories. They're all just gonna be called flood advisories to help us better message impacts and not have a variety of products that you try to remember, what they mean. So what does all this mean for you? Simply a minor name change for watches and advisories. There's really no changes to the hazards for what these products cover. So for flood safety, you never want to underestimate the power of water. The smallest amount of water can knock cars, people off their feet. So the 3 simple steps for flood safety: get to higher ground, don't drive into water, don't walk around barricades, and make sure you stay informed. And as with reporting severe weather, reporting rainfall amounts, reporting flooding is very beneficial to us. So any rainfall amounts, you have a rain gauge or another way to measure rain, you can send us a picture of whatever it is. If you want to have an official rain gauge, you can consider joining the CocoRaHS network. You can visit cocorahs.org and become a CocoRaHS observer, report your daily rainfall amounts to our office. If you're reporting flooding, water 1-inch impacts across areas, roads, yards, tell us the estimated depth of water. Don't put yourself in harm's way to get an actual measurement. Let us know if structures, vehicles, or roads are being impacted, if roads are being washed out, and try to be as precise as possible with the locations, cities, intersections if you can. And if you want to learn more about flooding or hydrology in general, later this fall, we plan on having a more hydrology-oriented SKYWARN Storm Spotter sessions, but that's still in the works right now. But if that piques your interest, be on the lookout for that in the next several months. So to wrap things up, before the storm, have a plan, know your plan, make sure you practice your plan. You don't want to be caught off guard. So kind of in the back of your mind, always know what you're going to do, where you're going to go, especially if you are under a watch for that day. So one last thing, you may have seen this going around social media last year, back in December. So on SKYWARN Recognition Day, which is usually the first weekend of December, we have our SKYWARN Recognition Days where we honor our spotters. It's the Weather Service way of saying thanks. And a page was developed to allow spotters to check in, no names or anything, just where you're at, when you were trained, As you can see across South Texas on this particular day, people checking in, there's a big gap in coverage across the brush country and the coastal plains. I mentioned earlier, this is the same area we have our big gap in radar coverage. So we need to try our best to fill this area in so we get better reports and a better idea of what's going on across those areas, especially during active weather days. So if you're interested in doing this, be on the lookout. Probably towards the end of November, early December, we'll be sending out these links where you can check in. So if you're interested in a SKYWARN certificate, you can head to weather.gov/CRP/SKYWARN. There'll be a tab for certificates. You can enter your first and last name. For the code section, this is case sensitive. Be all caps, SKYWARN, exclamation mark, create certificate, and you should have a printable certificate there in a few seconds. Lastly, if you joined our webinar and you're not from South Texas, here's how you can get in touch with your local contact. You can head over to weather.gov/stormready/contact. You can click on your state. So if you click on Texas, you can see the warning coordination meteorologist for each location. So for ours, it's Melissa Huffman. Say you're going down to, you're from Brownsville, Barry Goldsmith is your contact down there. Same will happen if you click on any state. Contacts from all across the state will come up. Send them an email, let them know you took our training and yet you're a trained storm spotter for their area. So with that, I'd like to thank everyone for joining our first webinar of the season. Hope you took away a lot from it. And I'll stay on the line for a bit in case there's any questions. You can just put them into the chat. Thanks again, everybody.